Okay, so solving one-step equations. When you're solving an equation, you're trying to get the answer. Okay? The key thing in an equation is it has an equal sign. Equation equal. Not too tricky there. Okay? So there's these things called expressions and there's equations. An expression is x plus 5. Just something like that. 2x. 2x minus z. Those are expressions. Once you throw an equal sign in there, now you have an equation. Okay? So, equivalent equations. Those that remain equal. You can write the word equal. I'm just going to use symbols. When the same transformations are done to both sides of the equation. Okay? And think about it. Remember, an equal sign is like a balance, like a scale. Okay? And the equal sign is in the middle. And whatever you do to one side tips it. So what do you have to do? You have to do the same thing to the other side to bring it back into balance. So that's what they're talking about here. The same transformations changes whatever. Add 5, add 5. Okay? Inverse operations are ones that undo each other. Okay, so the inverse undoes what you did. So if you add something, the inverse would be to subtract. If you multiply, the inverse would be to divide. You're just undoing what was done. Okay? Okay, solution to an equation. A value of the variable that works when you plug it in for the variable. Okay? Solve an equation. Find a solution for the variable. That's what you're trying to do. You're trying to find out what is x, what is q, which can sometimes be done mentally, which we're going to see in number 1, and sometimes you need to do it physically. Okay? So, yes, you should be able to figure this out without doing algebra. This is like a first grade problem. Okay? And if you think about it, I think we teach math wrong from early on. You know, you learn in kindergarten. Would you believe me that you were doing algebra in kindergarten or first grade? Anybody believe me? No, of course you don't. You were. Except here's what you had in grade school. Maybe, depending on where you were. You ever heard a problem like that? A box plus 3 equals 10. What number goes in the box? Guess what? 6. 6. I know. I'm just kidding. So, the number that goes in the box is 7, right? Okay? That's that mental math that I was just talking about. You should be able to figure that out. But the point is, you've been doing this since grade school. What number plus 7, sorry, my bad. What number plus 3 gives you 10? 7. Okay? That's just basic number facts. But when you had an empty box, you were doing algebra. It's just then when you got to middle school, they changed the empty box to a letter and called it algebra. And then everybody's mind just gets blown. Letters and numbers, they don't go together. It's okay, they do. Okay? So, my point is, if we taught that way from early on, instead of using a box, then when we got to algebra, it wouldn't be that scary, because you've been doing it forever. So if you just think about it, you actually have been doing algebra ever since you were a little kid. It's not that bad. Now, we get here to case number 2. You can't just look at this and probably go, oh, I know what the answer is. Okay? So you got to work it out. Okay, so when I'm doing algebra, I always tell my students, find the letter you're trying to solve for and circle it, or underline it. Okay? This is what you're trying to get back to. Okay? And you've got to undo everything in the opposite way you did it. Okay, now this isn't in the notes, but let's think about it. Order of operations. Remember this? PEMDAS, right? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. That's the order in which we must do things. Okay? We always have to multiply and divide before we add and subtract, right? Okay. When we are undoing, we're going backwards, right? Okay? So that is Sad method. Okay, we undo in the opposite way. So over here, when we're trying to undo, get back to x, we undo the addition. Okay? 7. Okay. So we do undo the addition subtraction first, and we undo this second. All right? So up here, we're trying to get to x. We're not going to divide yet, because we've got to get rid of that plus. So we're going to minus 3.0429. Again, like that balance we talked about, whatever we do to one side, we must do to the other. So we're going to minus 3.0429, which is just nasty. Okay? And so we type in our calculator. Everybody do it. Okay? And remember, this is a negative 158, so we're actually going further. So just think about this. Before you even put in the calculator, forget about the nasty decimals. Negative 158,000. We're subtracting 3. Should we end up with negative 155 or negative 161? If we have, we're starting with negative 158, right? So think about it. We owe $158,000. We're in the hole, $158,000. And then we borrow 3 more. Okay? Is this going to be going that way or that way? Bigger or smaller? Think about that, okay? So we're actually going to be more in debt. So we put in negative 158,690, and then we're going to subtract 3.0429. And we're going to end up with is negative 2.8x equals negative 158,693.0429. I ran out of space, sorry. It's a nasty number. So that 0 becomes a 3, because we're taking 3 more away. It's not going to be like, 87. It's going to be 93. Now, what's left? We want to undo the multiplication. So we're going to take the number in our calculator. It's already there. Don't clear it out. And divide by negative 2.8. Now what we get is x equals, it's ugly, 56676.08675. Yes, a nasty, ugly number, but that's our answer. Okay? So we take the problem we had, do the opposite thing backwards. So if it was adding, we subtract. If it was multiplication, we divide. All right, properties of equality. Okay, keeping everything equal, keeping everything the same. So the addition property of equality. If A equals B, then A plus C equals B plus C. In other words, if we add one thing to one side, we have to add the same thing to the other side. So think about it. If I took my age and add 10 years to it, I'd have to take your age and add 10 years to it to be the same change. That's all I'm saying. So if I start with my age compared to your age, me 10 years from now is going to be a certain age, you 10 years from now is going to be a certain age. To keep things equal, we have to add 10 to both sides. Subtraction, this is a really tricky one. Basically the same thing. You've got to subtract the same number to keep things equal, to keep things in balance. What you do to one side, you must do to the other. And then you guess where we're going here. A times C, B times C. And then division, A divided by C, B divided by C. As long as C is not what? What can we not divide by? What number can we never divide by, ever? 0, very good. We can never divide by 0. Okay? Try it right now on your calculator. Put the number in and hit divide by 0. Depending on your calculator, it will tell you different things. What does it say? Sin error, error, can't do it, dummy, something like that. Okay, that's an obnoxious calculator, but you can't do it. There's no way. And think about it. Here's why. If I had a bag of candy, or let's say pencils, since those are needed sometimes. Let's say I had a bag of candy, and I had 2, 4, 6, 8, 10. I had 10 pieces. Oh, I get one. 11 pieces of candy. Okay. Well, I could divide it up 11 ways, and everybody in here would get one piece of candy. That makes sense? Okay. I could say I don't feel like sharing and divide it one way. 11 divided by 1, keep all the candy for myself. But if I had this handful of candy in my hand, can I divide it 0 ways? It's got to go somewhere, right? I can't just make it go poof and disappear. It's got to go somewhere. That's why we can't divide by 0. Because you've got to divide it up somehow. It exists, right? A little bit of science. You just can't not exist. Marker. All right, so we can't divide by 0. Now, the substitution property. Okay? If A equals B, then B can replace A in any expression. If they're the same thing, you can swap them out. So who here plays a sport? Okay. So when you substitute in for somebody, coach takes that player out and you sub in. Okay? You sub in for the same position. You're not going to sub in a wide receiver for a linebacker. That'd be a bad day for them. Okay? You're not going to substitute a guard in for a center usually. Okay? So you've got to be the same position to be substituted for. So if A equals B, then they're interchangeable. B can be A can be B. Okay? And then the distributive property, that is when you send this in and you get A times B plus A times C. Okay? Now, you know yourself. I don't. But I'll tell you, from my years of teaching, the most common mistake on a problem like this is this. Don't write this down. Unless you want to write it down like that and put a line through it. That's the most common mistake with distributing, is not distributing through everything in the parentheses. Okay? Only distributing the first term. That's one of the most common things I ever see. So don't do that. Always make sure you go all the way through. Okay, so let's solve this now. Now again, also on the test, when we have tests in here, I will always grade on partial credit. So it is in your best interest to show your work. So right now, if you look at that and go, oh, -60, that's wrong. If you just write -60, you get no points. Because it's wrong, and I have no work there. But if you do this and write -60, you'll at least get partial credit because you showed me that you did the work right. Okay? You knew that you had to undo this -3 by adding 3. And the reason I'm saying show your work is, 1, you get partial credit. But 2, people will make that mental mistake and go, oh, -3. So -57 minus 3 in the calculator is -60. But we're not subtracting 3, we're adding 3. So this cancels here. And if you owe $57 to somebody, you pay back 3, now you only owe 54. You're still in debt, but you're not more in debt. You paid some of it off. Okay? So 2 reasons to show your work. Avoid simple, common mental mistakes. And 2, get partial credit if you do make a mistake. Alright? So this one, you have to subtract 15. You have to subtract 15. Because we're undoing the addition. Now, when we subtract, we're borrowing more money. So we're in the hole $33. We borrow $15 more dollars. We're more in debt. So that's going to be -48. Now, what's happening here? This fraction bar, that's where it comes from. That fraction bar means division. Okay, you're never going to see it written like that, but that's what the fraction bar means. The fraction bar means division. So, to undo division, the opposite, the inverse operation is multiplication. When you multiply, the 5's cancel, leading to n equals negative 60. 5 times 12 is 60, positive times the negative is negative. Over here we have multiplication, so we're going to divide. Make sure you divide by the negative number. And then 144 divided by 6 is 24. But, since it's positive divided by negative, my answer is negative 24. Okay, pretty much same thing here, more little practice. Except notice on here, our letters are on the right side. It doesn't matter. It doesn't matter which side you're on. You're just trying to undo it. So again, you find your variable. I forgot to do this on the first page. But I do suggest you do this. Circle it, underline it, something. Call attention to where that variable is. Now ask yourself, what's happening to the R? It's being increased by 20. Okay? So if I want to get back to where I started, I have to subtract 20 because I'm undoing the plus. So R equals negative 5. Or negative 5 equals R. Some people, if you feel better writing it like this, that's okay. You don't have to rewrite it. Some people just like to have the variable on the left side. Number 6. Again, what's going on here? Division. Okay? Put those dots as a reminder. The fraction means divide. So, how do you undo division? The inverse is multiplication. The negative 2's cancel each other over here. And I end up with negative 28 equals C. Alright? What do we have? The x being multiplied by 5. The way to undo multiplication is to divide. Whatever we do to one side, we do to the other because every equation is a balance. What we do to one side, we must do to the other. 5's cancel. 5 equals x, also known as x equals 5. The next one is a very important one to show your work on because, again, mental math might lead you to the wrong answer. Here's my k. It's being subtracted by 16, so I need to undo that. Now, remember, you're in the hole, $28. You owe someone $28, but you pay back 16. Just use a little common sense here. You know money. You're American teenagers. You understand money, right? Yes? Okay. So, you've got money. You owe $28, but you pay back 16. Does it make sense that your answer would be negative 44? If you paid off some of your debt, are you going to be more in debt? No. But negative 44 is a very common answer here, especially when you don't show your work. And this is what happens. People just look at this, go, oh, minus 16, boom, negative 54, and move on. You've got to think about whether your answer makes sense. You're in debt, you pay back 16, you are less in debt. You only owe 12 now. So your answer is still negative, but it's less negative than it used to be. Your debt is partially paid off. Okay, number 9 is tricky. What's tricky about number 9? Double negatives, yeah. So when you subtract negative, you're really adding the opposite, right? Okay? You subtract a negative, you're really adding 4 instead of subtracting negative 4. So that's really d plus 4. And now all we do is minus 4. Cancel. D is equal to negative 16. Now this is one of those ones where you're more in debt. You owe somebody 12 bucks, then you borrow 4 more. Okay, so on example 10. Now this time, this one's a tricky one. There's my t. It's being multiplied by 1/7. Okay? Now, most times you say, oh, well then you divide to undo multiplication. Well, we don't divide by fractions, right? We don't divide by a fraction. We multiply by the reciprocal. So, what is the reciprocal of this? We're just going to multiply by 7. Now, let's think about why that is. We could rewrite this problem like this. And then everybody would know what to do. T divided by 7. Because 1 times t is just t. Alright? So, if we wrote it like that, everyone in here would know multiply by 7. The fraction thing throws you off. Okay? So we multiply by the reciprocal, which is just 7. So this undoes this, the inverse. So we get, I don't know why I did that. So t equals 7 times 4 is 28. 98. T is 98. Now, here's the thing. Let's say this was 2 over 7. Then we would multiply by 7 over 2 over 7 would be 7 over 2. Right, we just flipped it. We multiply by the reciprocal. The reciprocal is just the fraction standing on its head. All right? All right, here's my variable. It's being divided by negative 3. To undo that, we multiply by negative 3. The 3's undo each other. M equals, negative times negative is positive. And then 24 times 3, positive 72. 24 hours a day, 3 days, 72 days, 72 hours. Okay? But remember, negative times negative is positive. And then here's my variable. But remember, we have subtracting negative, so that's really positive 16. So we're going to subtract 16 right here. Cancel. K equals 12. 28 minus 16. So you had 28 bucks, you bought something for 16, you got 12 left. Two more and then we're done. Okay, match each situation to the algebraic equation that represents it. Okay, so this is the part that people hate about algebra. And like I said at the beginning, we're in a Latin classroom. Math is a foreign language. This is where we translate. We're looking for things that match up. So it says x plus 7 equals 9, x minus 2 equals 7, 9 minus x equals 7. It says you have X dollars. You have a certain amount of money. Your friend repays you $7 he owed you. Okay? You now have $9. Repaid. You got to think in your mind. Does that mean your money is going up or going down? It's going up. So repays means plus. Put a plus over that. We're trying to see the words that what they mean in math. We're translating. So for example, I used to be pretty fluent in Spanish. I don't remember much Spanish anymore. So if I went to Mexico or Spain right now, I would have to take one of those traveler's dictionaries, one that translates simple things for you. So let's say I'm over there and like, I need to find the bathroom real quick. I don't care about sounding perfect, using every correct tense. Excusez-me, por favor. ¿Dónde está el baño? I don't care about sounding perfect Spanish. I just need to find 2 words. Where? Bathroom. So I look up where? Donde? Bathroom. Baino. And I go up to someone that looks like they live there and I go, Donde Baino? And they're going to say, stupid American, it's down there. Because I just slaughtered their language. But I got the point across, right? Where? Bathroom. Same thing here. When you're translating word problems, and everybody hates in math, you just are looking for the key words. Repay, money's going up. Borrow, money's going down. Okay, you're looking for those key words. So you had this, you've got plus 7, so which one's that going to be? That one's going to be A. You now have $9. That's the repay right there, the plus. The temperature was X degrees. It fell 2 degrees. If it fell, did it go up or did it go down? Down. Is that add or subtract? So we're looking for X minus 2. B. A 9-foot post extends X feet below the ground and 7 feet above the ground. What was the original length of the post? Well, below the ground means subtract. So a 9-foot post below the ground, this amount, leaves 7 feet. So that's C. You're just translating word for word. You're not trying to be beautiful and perfect pronunciation. You just want the key elements. Last slide, we're there. The normal high temperature in January in Bismarck, North Dakota is 20 degrees. The low temperature is -2. What's the difference? How many look at this problem right now and want to say 18? Raise your hand. Nobody? Oh, so smart. No, that is the most common mistake, though, is people always want to say 18. They just look at me, oh, 20 minus 2, 18. But let's think about it on temperature. So we got the temperature reading like this, right? That little bulb fills up with red stuff or mercury. Okay? So let's think about where 20 would be and -2. So let's say 0 is right here. All right? 20 is going to be up here somewhere. -2 is down here. Okay? So how far is it from here to here? No, just from here to 0. 20. And how far is it from here to here? 2, right? 2 degrees. So the total is 22. Not -22, just positive 22. It's just a difference. But what this mathematically would be is 20 minus -2, which we've already talked about, becomes 20 plus 2 to 22 degrees. This is one of those ones where it helps draw a picture. It doesn't have to be a very fancy picture. You don't have to draw a bull. It can be as simple as a line like this. 20, -2, what's the difference? Doesn't have to be that fancy. Okay? You're going from here down to here. And again, if you just look at it, a lot of people would go, oh, 18. But you got to remember, from 20 down to the negative region, it's already 20 just getting down to 0. Then you got to go further. Okay? If this was a positive 2, the answer would be 18. But being some of it's positive and some of it's negative, you're actually subtracting a negative. Okay. The perimeter. The perimeter is the distance around a shape. Of an equilateral triangle, I can speak. That means all sides equal. Is 54 degrees. Sorry, centimeters, I got stuck. Write an equation to help find the length of each side. Okay, there's 2 ways to do this. How many sides are a triangle? 3. And they are all equal. And they add up to 54. Nope. That's one way, right? They're all the same. All 3 sides are the same, so x plus x plus x equals 54. Or, quicker way is 3 times x equals 54. Which, if you think about it, if you write it this way, your next step is going to be to combine like terms, and what are you going to end up with? 3x equals 54. So you're going to be there anyway. It just depends on what you see first. Neither one's right or wrong. One just a little quicker. Now let's find out what each side is. Divide by 3. X equals 18. So each side of the triangle is 18.